Hey everyone, welcome back. It's another GRE Prep Hour. I'm your host, Tyler, and I am an instructor with Manhattan Prep. And for these prep hours, what we like to do is just kind of go deep on a topic that we don't really get an opportunity to do otherwise. And today, what I've got planned is number lines. So going deep on those, got some interesting info and tips and tricks to share. And if you've never been to one of these before, the way it works is they are taking place live in a Zoom room right now. It's also going to get recorded and thrown up on YouTube later. So whether you're here live or whether you're watching it on YouTube, big welcome to you. And if you're in the Zoom room right now, why don't you in the chat box tell me where you're connecting from? It's myself. I'm in San Francisco, California, the city by the bay. It's a pretty gray day. We had the bomb cyclone come in here, so it's going to be a rainy few days. We got New Jersey in the house. I'm watching The Sopranos right now. I'm in season 3, so it's been a good journey. Um, cool. So, as mentioned, we're talking about number lines today. And the first exercise here is there are 4 different statements up on the screen. And the question is that statement always true? Can it sometimes be true? Or is it always false? I want you all to take a minute, debate it for those 4 different options. And then if you're in the chat, if you're in the Zoom room, go ahead and chat me your answers. If you're watching on YouTube, pause the video, give yourself a minute to think, and then we'll review this in a couple minutes. All right, let's talk about these four statements here. First thing I want to say about number lines on the GRE is that they are going to be drawn to scale. There's a few different things that are drawn to scale on this test, the other ones being data interpretation, right? If you've got a chart or a graph, be it a pie chart, line graph, bar graph, anything like that, that is always drawn to scale. If they ever show you a diagram and explicitly write drawn to scale along with that diagram, it's safe to trust that they aren't lying to you. And then I kind of group these together. If you see coordinate plane questions where the X and Y axes are drawn in, or if you see a number line, those are going to be to scale as well. So what's going to kind of anchor you in this diagram is you've got 0, 1, and -1. Those points are supplied, and you can tell it's drawn to scale, like it's well placed. Trust that -1, 0, and 1, that's all something you can eyeball. But where you have to be careful is you can't make assumptions about those unknown values. There's certain assumptions I can make, like Q, I know it has to be in between -1 and 0, but where exactly it's going to fall there is a little murky. So we'll get to that in a second. The first statement, S plus Q is greater than 0. That is always true because you know S is something bigger than 1. Q is something in between -1 and 0. So Q is a negative fraction. So something bigger than +1 plus a negative fraction, that's still going to remain positive. The murkier one here is number 2. That's a statement that may be true or it may be not. I need more information to really boil it down. Because one way to interpret this, I could say maybe Q is -0.5 and maybe P is -1.5. And in that case, multiplying them together, I would get something like 0.75. And T, if I'm eyeballing that one, I might say something like 0.6 or maybe 0.66, like really near that 2/3 mark. And I can estimate it there, but I can't assume that it's exactly 2/3. So if -1.5 and -0.5 are my PQ values, then it looks like that's bigger than T. But I can't make that assumption safely, right? An equally valid interpretation here is maybe Q is something more like -0.4 and P is more like -1.4. And if I multiply those two together, I'm going to get 0.56. And that would be less than my initial estimation for T. And again, T itself was something I was estimating here. So that's all to say, nothing is really safe with statement 2. It could be true, it could be not. I need more information. All I really know about P is it's less than -1. Q is a negative fraction. T is a positive fraction. I can't really boil it down any further than that, though. Number 3, though, T minus Q equals 2. That is something I can definitely say is always false. If I'm starting at a positive fraction and I subtract a negative fraction from it, it's going to make that positive fraction bigger, but it will not get it all the way to 2. Right? Even at the most extreme, if I had a huge positive fraction, like 0.999, and I subtracted a large negative fraction from it, like -0.999, that's still going to give me something smaller than 2. So number 3 is always false. And then finally, number 4, S minus P versus R minus Q. That is an always true statement. You're starting at S, which is bigger than 1, and then you're subtracting P, which is further left of -1. So that's going to push that whole result further right on the number line. Whereas with R and Q over here, put those two in orange. You're starting at R, you're subtracting a negative fraction from it. So it's also going to move further right, but with a smaller magnitude, right? You're only adding a fraction to R. So S minus P, that ends up further right. That is the bigger value. So major takeaway here, number lines are going to be drawn to scale, but you only want to really treat the concrete values there as the actual numbers, like 0, 1, and -1. When it comes to variables on the number line, you got to be careful. You don't want to just eyeball it and assume t is exactly 2/3 or something like that. You can acknowledge that t is a positive fraction between 0 and 1, but it's going to be harder to split the hairs further than that. Another safe thing is that relative positions are accurate. So between R and T, R is the smaller positive fraction, T is the bigger positive fraction. But yeah, be careful with the variables. Don't make unnecessary assumptions. So now let me show you all a more realistic GRE problem. Here is a quantitative comparison. I'll give you a couple minutes and then we'll discuss. Okay, let's talk about this one. First of all, I want to talk about the upfront information. They tell you R is equal to -2Q. The fact that there's a negative being multiplied there and the fact that R is further right, that guarantees two things. R has to be a positive value and Q has to be something negative. If Q were positive, R would become negative, and then I can't have a negative be further right. So that kind of breaks the law there. Likewise, if they were 0, R would be 0 as well, and that's kind of breaking the math laws because they're spaced out. They aren't just stacked on top of each other. So Q must be negative, R must be positive. And then the other thing I want to point out here is when it comes to midpoints, midpoints are the average of the endpoints. So let's pick some numbers and see what happens. If I make Q be a value like -2, R is -2 times -2, so R would be 4, which means S is going to be the average of those two. So 4 plus -2 divided by 2, that's going to get you 1. So there's a case where S is larger than 0. But when I'm number testing, I never prove an answer after just one test. I got to select some other numbers and see what happens. So I tried a negative integer, -2. Let's see what happens when I use a negative fraction. If Q were -1/2, R is -1/2 times -2, so R would be +1. And then from there, S is still the average of those two endpoints. So -1/2 plus 1 divided by 2, that's going to get you 1/2 over 2, which is 1/4. And the pattern emerging here is that no matter what happens, S is always going to be something bigger than 0. That as I make Q itself closer to 0, S will move closer to 0, but I can never make S be negative or be 0 itself, right? Because R is always double that distance that Q has into the positive area of the number line. So there's always going to be more positivity than negativity between Q and R, and S will be at the midpoint, and S is always going to be in that positive zone. Biggest takeaway, though, is just conceptually, anytime you're asked about midpoints, whether it's on a number line or the coordinate plane, the easiest way to find that is taking the average of the endpoints. Okay, here's another midpoint question. I'll give you a couple minutes. Okay, so if I were to draw this one out, I've got this AB on a number line, and C is the midpoint. So I'm just drawing C right in between those two. And then D is now the midpoint of AC. So I'll have D right there. And I'm trying to figure out the ratio of AD. So maybe that red line right there to CB, to that red line right there, versus the ratio of AC to AB. And just visually, you might be able to work out the answer. If you're not sure visually, another good thing to do is pick your own numbers. That if A is 0, I might say B is 4. The midpoint C would be 2. D, the midpoint between AC, could be 1. And AD to CB, that's going to be 1/2. And AC to AB is going to be 2/4. And no matter what numbers I pick, because it's a ratio, that same general ratio is always going to apply. These two are always equal, no matter what. Okay, next up, I got one more midpoint question for you. This one's a little trickier. Give you a few minutes here. So quantity A is interesting here. They're asking for the location of Dave's house when it's as close as possible to 0. And in order to make the midpoint be 0, X and Y would have to be opposites. For example, if X were -5 and Y were +5, then the midpoint is exactly at 0. But check out our restrictions. X can only be negative values. Y could be negative or positive. So if I want to move that midpoint, Dave's house, as close as possible to 0, I'm going to stick X as far right as it can go, which would put it at -3. And Y, unfortunately, I can't push all the way to 3. I've got that hard cap of 2. But making Y 2 is as close as I could get to that ideal of 3. So now I just need to calculate what would the midpoint be. And it's the average of the endpoints. So -3 plus 2 over 2, that's going to be -1/2. And that's as close as I could get Dave's house to 0. So quantity A and quantity B are equal here. Okay, so we had fun with midpoints. We're going to check out some other number line related stuff next. Here is another quantitative comparison. I'll give you a few minutes. So in the diagram, it looks like A is kind of half the distance from 0 as B. So if I wanted to pick some numbers to test here, I might say something like A is -2 and B is 4. And in a case like that, -2 times +4 is -8. That is not as big as quantity B. So there's a case where quantity B is bigger. So I can at least eliminate choice A and choice C. But can I find any numbers that would reverse that relationship? Can I find a situation where it's not always quantity B being the bigger value? And what you need to do here, when I say don't make assumptions, part of that is not assuming integer values. That A and B could actually be fractions here. And if they were fractions, like if A were -1/4 and B were 1/2, that's going to reverse the relationship. Quantity A would be -1/8, and that is a bigger value than -1. And as soon as you find two different relationships, you've proven the answer is D. So careful with those assumptions. When you have an unlabeled number line, don't assume everything is an integer. Be open to fractions as well. Okay, here is what we call a numeric entry problem, where there are no answer choices. You just need to do the calculation yourself and then fill in the box. Give you about 3 minutes with this one. Before I can say anything about Y and Z here, I got to make sense of the numbers I do know, because I'm provided 3/4 and 41/8. And I know the tick marks are evenly spaced. So count up those tick marks and you'll find there are seven regions of equal distance between 3/4 and 41/8. And I'm just going to call each of those hash distances n. So now I can form this equation that 3/4 plus 7n, 7 of those distances, is going to put you at 41/8. So now I just need to solve out for n. So subtract that 3/4, then give yourself a common denominator, carry out the subtraction, and then scale both sides down by 7. And now you know the n value. Each one of those spaces is 5/8 of a unit of distance. But the question wasn't, what are those hash marks? It's what's the distance between y and z? So looking at y and z, count up those spaces. There are 4 hash marks in there, which means the space between them is 4 times that 5/8, and that comes out to 2.5. 2.5 is your correct answer. And the sort of takeaway I'd recommend for this is introduce a variable for the space between known values. All right, so calling each one of these its own n unit. That's what really unlocks the rest of the problem. Okay, next up, I've got another quantitative comparison. Try it out. One thing you can do to make any quantitative comparison simpler is ignore what the two quantities have in common. And what I mean by that, quantity A is B minus C, quantity B is B plus A. A trick I can do here is just subtract that B value from both quantities. And now the much simpler comparison is quantity A is negative C and quantity B is A. So just like you can subtract or add the same value to both sides of an equation, you can do that to both quantities, and it's not going to impact what the relationship is between them. So negative C versus A, I see C is between 0 and 1. If I had negative C, I can really just kind of mirror it around 0. So to my eyes, that means negative C would be just inside B right there. So positive C between 0 and 1, negative C is between negative 1 and 0. And A is even further left of negative 1. So I've proven negative C is always further right on the number line, so it is the bigger value. I don't need to worry about the B's at all. Like if I added the B's back in, it's the same result. Adding or subtracting the same value to both sides of an inequality does not affect the relationship. So quantity A is bigger. Okay, so this next one is going to be somewhat similar, but instead of simple addition and subtraction, we're now going to throw exponents into the mix. Check this one out. So imagine for a moment that z were 1/2. Right, you can tell it's a fraction. It's between 0 and 1. So just say it were 1/2. If you cube z, z squared would be 1/4, and then z cubed would be somewhere right around there. Right, it would be 1/8. So when you cube values bigger than 1, they get bigger. But when you cube a fraction, it moves closer to 0. It becomes smaller and smaller in its magnitude. Similarly, when I cube w, it's going to approach 0. So if w were negative 1/2, w cubed would be negative 1/8, somewhere around there. And no matter what kind of fraction it is, right, I could have a fraction really close to negative 1, like negative 9/10. Still, the act of cubing it is going to push it further right on the number line, closer to 0. And now, quantity A, it's taking that w cubed and subtracting 1 from it. So if I moved 1 left on the number line, this point right here is about where w cubed minus 1 would fall. But then I'm also taking the absolute value. And the rule for absolute value, be careful. The somewhat naive definition I hear is that absolute value is always positive. It's slightly more complex. Absolute value is always non-negative. Don't forget that it could be 0 itself. That's not the same as being positive. So the absolute value of w cubed minus 1 is going to flip around to the other side of the number line, right here. And because z cubed is already further right of 0, nothing's going to change between z cubed and the absolute value of z cubed. But I've proven w cubed minus 1, that is further right on the number line, so it is the bigger value. So A is your answer. And for me, the biggest takeaway here is when you square or cube really any exponent, a fraction, it moves closer to 0. Right? If you start with a positive fraction, it's going to move further left towards 0. If you start with a negative fraction, it's going to move further right, but it's still towards 0. And one other complication is like if we were doing an even power, if w is negative, then w squared becomes positive, but it's still closer to 0 than w to the first power was. So this is always a true statement. Squaring or cubing a fraction, it pushes it closer to 0. If you start with a negative base, it kind of complicates because your even powers will always be positive, but the negative powers will, the odd powers will always be negative. So yeah, extra little bit of complication there. But for this particular problem, quantity A is always bigger, no matter what. Okay, this next one is a fun continuation of this idea of exponents being represented on the number line. It's pretty tough. Try it out. Okay, so the starting point here is you want to begin with what you do know. This hash is 2 to the 5th. This hash is 2 to the 6th. So remember this idea of introducing a variable to find that space between the known values. So say that's n right there. And some people at this point, they might be tempted to write 2 to the 5th as 32 and 2 to the 6th as 64. I'll tell you, that's a bad idea. Why do I know that's a bad idea? It's because before you start any solution, you should look at the answer choices. And every answer choice here has maintained that base of 2. They did not convert 2 to the 5th into 32. They're keeping the powers of 2 in the answers. So life is going to be easier if you make your scratch work mirror the answer format. So keep the base of 2, keep that exponential form. To find out what n equals, it's the difference between 2 to the 6th and 2 to the 5th. And to simplify that, what I'm going to do is factor out the greatest term those two numbers have in common, which is 2 to the 5th. So I pull the 2 to the 5th out. That leaves me 2 to the 1st and 1 inside my parentheses. And 2 to the 1st minus 1, that's just 1 itself. So I've seen n is equal to 2 to the 5th. There is 2 to the 5th distance there. But the question is not what's that space. We need to figure out what value is represented by x. To figure that out, I can start at 2 to the 5th and recognize I go 4 of those equally spaced ticks backwards. So it's 2 to the 5th minus 4n, and I know n is 2 to the 5th. And if you're a little confused at this point, recognize there's that kind of hidden coefficient of 1 in front of that 2 to the 5th. So you have a single 2 to the 5th minus 4 2 to the 5ths. That is minus 3 2 to the 5ths if you simplify it. So your answer is D. So pretty fun one, lots of levels there. The keys, create a variable for that space between, and make sure you glance at the answers before you start solving and make your scratch work look like the answers from the get-go. Okay, I got one last problem to show you all. It's gonna be a fun one. Here it is. Okay, so here is my favorite way to start this problem. It's using a variable for the space between those points again. But I'm not going to call B seed n. I'm going to call A to B n and C to D n. And those values are 1/3 BC, which makes BC 3n. So I introduce my variable. That's going to make my life a little easier. And now for what I do know, the parts that are locked in, A is 1/5, D is 1/2, and there's 5n units total between them. So 1/5 plus 5n makes 1/2, and I'm just going to solve out for 5n. And at this point, I don't like working with fractions, so I'm just going to multiply everything by 10 to clear the denominator, which means n itself is 3/50. And my goal here is to find the value of coordinate C. So I'm going to start at 1/2 and subtract 1n to get to C. So 1/2 minus 3/50. Give yourself a common denominator there. So that's 25/50 minus 3/50, giving you the correct answer of 22/50. And note, for GRE problems where you enter a fraction like this, any equivalent fraction is counted correct. So if you got 44/100ths, anything else that reduces to that same value is also going to give you a correct answer. All right, so that was our last problem of the day. We're going to start wrapping up here. So I'm going to clear my notes. And I encourage you to kind of think about your biggest takeaways as well. For me, number lines recognize they are drawn to scale, but that doesn't mean you can make assumptions when it comes to variables labeled on those lines, right? All the hard-coded numbers, if there's any integers or fractions marked there, those are all for sure in the place they're going to be, but variables have a bit of wiggle room to them. And furthermore, when nothing's labeled, don't assume that you're looking at integers. You need to be open to the possibility you're looking at fractions. We saw a few problems with the exponents. Recognize when you have a fraction and you square it or you cube it, that's going to push it closer to 0. If you start with a negative base and it's a negative fraction and you square that, it then becomes positive, right? A square or any other even power could never be negative itself. But provided that that original base is a fraction, anytime you square it, cube it, fourth power, etc., it's getting closer and closer to 0, regardless of what side it is on the number line. Compare that to the values you're probably more used to. If you have something bigger than +1 or less than -1, when you square or cube those, they get further from 0. They get more positive or more negative. Additionally, don't forget the rule for midpoints. You really just take the average of the endpoints. That's the simplest way to calculate that. And finally, the big move I'm a fan of here, it's introducing a variable and having that represent the space between values on the number line. So that's what I was calling n throughout this lesson, and that can really open the door on a lot of these problems. All right, so that's it for today. Hope you enjoyed the prep hour. If you want to check out more in the future, there should be a link in the video description on YouTube. I'm also putting a link in the chat if you want to check that out. And please also note that we do a 9-class course at Manhattan Prep, and session number 1 is open to the public. So if you don't want to commit to paying for the full course, just come check out session 1, whether it's with me or another instructor. Those sessions are always free. So I hope to see you either at a trial class or another free prep hour in the future. I'm going to go ahead and close out the room. Thanks for being here and enjoy the rest of your day.